Hi students, all of you welcome. Welcome to Sunil Engineering Academy. I am Sunil Kumar Bandar. Students, in this general science, physics, we have already completed the topics electricity, magnets and magnetism, work, power, energy. And recently we have started force and motion. In that also we have completed two sessions. It is another session on force and motion. Okay. These sessions are useful for all your competitive examinations. So try to watch each and every session to get better knowledge, and also please share to all your friends. Let me check up to which we have completed. In the motion, we have completed all these topics. So you can watch all these in the playlist. Okay. So up to projectile motion topic we have completed. Now we are going to discuss the very important thing, Newton's laws. Newton's law of motion. Newton law of motion. We have three laws. After that, Newton's law of gravitation and some important topics on weight and mass. Okay. After that, we will discuss the Kepler laws and almost we end this topic. Okay. So all of you please be concentrate. Newton's law of motion. I think all of you know very well about the Newton's laws of motion. Newton's law of motion. Newton has given three laws on this motion. Correct? Coming to Newton's first law of motion. Newton's first law of motion. Okay. So this is also called as law of inertia. Law of inertia. It is also called as law of inertia or law of Galileo. You can also call this one as law of Galileo. Inertia. Okay, so what it said, Newton's first law will give the definition of force. Newton's first law will give the definition of force, and also it gives the definition of inertia. Definition of inertia or law of inertia. Okay, so first law will gives take red color. It gives definition of force. Okay, so has given the statement like, if any body is at rest. Okay, if any body is at rest, for example, if it is a 1000 kg stone, it is always in that rest position only. It is always in that rest position only. If any object is in moving, it is always in the moving only. Okay, so if any body is at rest, that is stand still, it is always in the rest only. If any body is moving, it is always in the moving only. Unless, okay, unless if you apply any external thing, unless if you apply any external thing, in that case, that is up to that, it is always rest, it is always in the mode. For example, if you apply some external thing, some force, if you apply some external thing, then it is moving, means that means we have applied some force. If anything is moving and we are going to stop this, if we apply some external thing and we are going to stop this, means that means we have applied the force. That means it gives the definition of force. That external thing is nothing but force. Okay, if any body is in rest, it always in rest position only. In rest position only. If the same way, if any body is in motion, in motion. It is always in motion. Always in motion. Up to which? Until unless if you apply any external thing. Any external thing. Okay. That external thing is called as force. That external thing is called as force. That means if you apply the force, then rest position will becomes moving. If you apply the force, moving position will becomes a stop position. That external thing is nothing but can say force. So Newton's first law will give the definition of force. Okay, definition of force. So this inertia is nothing but it always opposes the change in position. Due to inertia, always opposes the change in position. So if anyone is rest, if it want to move, it opposes. If anything is moving, if it want to rest, it opposes. Okay, so it opposes the sudden changes in the position. Okay, opposes the sudden changes in the position. So note down, it is the property of a body by virtue of it is the property of a body by virtue of which the body opposes the change in position. Opposes the change in position or change in initial state. Change in its initial state. If its initial state is rest, initial state of rest. If initial state is motion, motion. Okay, motion with uniform speed. Speed on a straight line. On a straight line. Okay. So if any body is in rest, it is always in the rest only. If any body is in motion, it is always in the motion only until unless if you apply any external thing, that external thing is nothing but force. Okay. So we can define the first law like this. Or we can also say the first law, or we can also do the first law. Every body maintains in its initial position or initial state. Every body maintains in its initial state of rest or motion with uniform speed on a straight line unless an external force act on it. An external force act on it. Force acts on it. Okay. The means in simple words I have given here. You apply any external thing, then only rest will becomes moving will becomes rest. Okay. Some examples. These examples are very important. Some examples. Let us take some examples. For example, when a bus or train When, for example, when bus or train or horse starts suddenly, starts suddenly, then what will happen? The passenger or rider. Okay, so here, for example, let us take it is a bus. In the bus, the person is there. Okay, both are at the same place. Both are at the rest positions. Whenever bus only starts suddenly, that means bus is moving from that place to that place. Okay, bus starts suddenly, the passenger or rider. So previously it is in which position? Back position. Correct? Okay, so whenever the bus is moving from this place to this place, then passenger also moves that same now. But the passenger tries to occupy its previous state. Tries to occupy his previous state. Why? Because that is nothing but law of inertia. It opposes the sudden changes in position. From this place to this place, it want to move. This person always opposes because of law of inertia. So that's why the person backward, bend backward to get its previous position. Okay, so whenever bus or horse starts suddenly, the passenger or rider bends backward, bends backward. If they brake, then bends forward. Okay, so we can experience this one. Okay, when a running bus or horse stops suddenly, then passenger or rider bends forward. Okay, and one more thing. When we give a jerk to tree, when we give jerk to tree, then fruits are fall down due to inertia of rest, due to inertia of rest. Very important question. Yeah, rest. Okay. And when a blanket or coat, this is also important. When all these examples are very important, guys. When a blanket or coat is beaten by a stick, then dust particles fall down. Beaten by a stick, the dust particles fall down. Okay, or dust particles are removed. Okay, so all these are examples of law of inertia or Newton's first law of motion. Now coming to second law of motion. Very important. Newton's second law of motion. So what I said in the first law will give the definition of force or law of inertia. Second law will use magnitude of force. It gives, this is also important, this point also gives magnitude, that means value, magnitude of force. Okay, magnitude of force. He said that the rate of change of momentum, the rate of change of or the change in momentum of a body is directly proportional to force, directly proportional to applied force, applied force. Okay, so that means you can say momentum. What is the momentum, guys? I have already given the momentum in the previous session. Momentum P is equal to mass into velocity. Okay, so rate of change in momentum, rate of change in momentum is nothing but rate of change means differential dv by dt. Dt is the rate change in momentum. Okay, rate of change in momentum is dv by dt. So according to the second law, applied force is proportional to dp by dt na, dp by dt, momentum denoted with p. Okay, so dp by dt, that is proportional to d by dt of mass into velocity. Always mass is a constant, then dv by dt you will get. Okay, so that is proportional to m into a, m into a. So we can say f is equal to some constant into m into a, or simply if you take the constant as 1, f is equal to ma. So this is the magnitude of force. This is the magnitude of force. Units you know very well, newtons, or mass kg, acceleration meter per second square, kg meter per second square, kg meter per second square. A is the acceleration, that is equal to dv by dt. Okay, from this we can also say that f proportional to dp by dt. From this, let us take f is equal to dp by dt. From this, dp is equal to f into dt. Okay, so that means you can say here change in momentum, just not rate, just change in momentum. Very important question. Change in momentum is equal to force into time is the impulse, impulsive force, impulsive. Okay, very important. Change in momentum is equal to impulsive. Okay, from this one you can also get the number of bullets fired, the number of bullets fired. Okay, so in case of bullet question, change in momentum is equal to force into time na. So momentum is equal to mass into velocity, that is force into time. This is for whenever we have one bullet. If n number of bullets, then n into mass into velocity is equal to force into time. So n number of bullets is equal to force into time by mass into velocity. Time t in seconds, force always in newtons, mass always in kgs, velocity always in meter per second. Then you will get number of bullets fired per second. Okay, so it is also very important in the numerical based questions. Okay, and here some examples. Force is proportional to m into a na. If A is equal to constant. If we have a constant acceleration, okay, then if mass is more, we have to apply more force to move. Okay, so it is F proportional to M. If the mass is more, we have to apply more force. If mass is constant, in this case, F proportional to acceleration, we have to get more acceleration, we have to apply more force. To get more acceleration, we have to apply more force. Okay, to apply more force. Now coming to Newton's third law. Newton's third law. Newton's third law is very simple. Newton's third law is for every action there is equal and opposite reaction. For every action there is an equal and opposite reaction. Okay, that is force F1 is equal to minus F2. Okay, for example, if you throw a ball on the wall, so whenever the ball strikes the wall and it comes back. Okay, and also motion of jet, motion of rocket. Examples of Newton's third law. Note down examples, these are very important. Recoil of gun, recoil of gun, motion of jet or rocket, swimming, and a sailor jumps out from boat. Out from rowing boat. In this case, what is happening? Whenever sailor is forward, boat is backward. Boat is backward. Okay, boat is backward. So these are the three important Newton's laws. Okay, in the next session we will discuss Newton's law of gravitation and the gravitation. After that, Kepler laws and weight. Okay, the difference between mass and weight. Okay, students, all of you, thank you so much for watching, and also please share the session to all your friends, and also click on like option, and also join the Telegram group. I have given the link in the description box. Okay, thank you so much, guys.